Hi to all. Yesterday, series parallel connection of passive elements completed. Now, what is series connection? Series connection is nothing but one element second terminal is connected to second element first terminal, and second terminal is connected to third element first terminal, so on, to form a closed path. Then those elements are in series. We can say that those elements are connected in series. Okay, so now previously in series connection, current must be same. So these are the basic key points related to series and parallel. Series and parallel. So coming to series connection, here current must be same. I is same. In parallel combination, voltage is same. Now, in series combination, coming to voltage, V total equals to V1 plus V2 plus so on. Coming to parallel connection, I total equals to I1 plus I2 plus so on. Voltage, current completed. Now coming to resistance. So R total in series combination, R total equals to R1 plus R2 plus so on plus Rn. Total resistance in series connection. Now coming to parallel connection, 1 by R total is equals to 1 by R1 plus 1 by R2 plus so on. Now coming to capacitor. So capacitors are connected in series. The total capacitance is 1 by C total is equals to 1 by C1 plus 1 by C2 plus so on. Coming to parallel combination, C total is equals to C1 plus C2 plus so on. Now coming to inductance. Inductors are connected in series. Now L total is equals to L1 plus L2 plus so on. Coming to parallel connection, 1 by L total is equals to 1 by L1 plus 1 by L2 plus so on. Okay, so previous class I have discussed about series connection and parallel connection of passive elements. In series connection, current must be same, voltage divide. In parallel connection, voltage same, current is divided. Means current I total equals to I1 plus I2 plus so on. Now based on these formulas, now we can solve small problems. Those are related to series and parallel. Now suppose I am considering one problem. Now find the total resistance. Find the total resistance for the following circuit. Okay, now I am considering one simple circuit, R1, R2, R3. Now this is the, I am not giving any supply here. Okay, negative, positive, this is 5 volts, and here 10 ohm, 5 ohm, 20 ohm. Okay, for this circuit, find the total resistance. So it is a series circuit. Now R1, R2, R3 are connected in series. Now in series combination, what is the total resistance formula? That is R total is equals to R1 plus R2 plus R3 plus so on. Now what is the value of R1 here? 10. What is the value of R2? 5. What is the value of R3? 20. So 20 plus 5, 25, 25 plus 10, 35 ohm. This is the total resistance for this circuit. Okay, so find the total resistance. If again suppose consider find the current flowing in this circuit. Find the second question. First question is total resistance, and coming to second question, find the total current in this circuit. So after completion of calculating R total, already we know the voltage, that is total voltage. So V total is equals to 5 volts. Now based on these two, we can consider calculate I total. So what is the formula for I total ma? I total is equals to, according to Ohm's law, I equals to V by R, means V total by R total. So how much the V total here? That is, we can apply 5 volts here. So 5 divided by how much the R total ma? 35. Okay, 5 ones are 5 sevens are. So I total is equals to 1 by 7 amperes of current is flowing in this circuit. Okay, so this is the simple problem related to series resistance. Now coming to another problem. Find the total resistance. Find the total resistance. Find the total resistance for the following figure. Okay, now find the total resistance. This is A, this is B. Find the total resistance, that is from A to B. Here he given the 10 ohm and here he given the 10 ohm. So R1 is 10 ohm, R2 is also 10 ohm. Now what is the formula for R total for parallel combination? That is 1 by R total equals to 1 by R1 plus 1 by R2. So 1 by R total is equals to 1 by R1 plus 1 by R2. Here only two resistors are connected in parallel. Okay, so now 1 by R1. R1 is nothing but 10 plus 1 by R2 means 1 by another 10. So what is LCM here? Both are same. So we can consider 2 into 1 by 10. So 2 ones are 2 5s are. So 1 by 5. This is 1 by R total. So we need to, here R total we want. So R total is nothing but R total is equals to 5 ohm. R total is equals to 5 ohm. So what is the formula for parallel connection? 1 by R total is equals to 1 by R1 plus 1 by R2 plus so on 1 by Rn. Okay, so now this is the second based on the parallel connection. Now one is series connection completed, another one is parallel combination completed. Now coming to capacitors. See, what is the unit of capacitance? So capacitance is measured in terms of farads. Okay, so now the question is find the total resistance. Find the total capacitance. Find the total capacitance. Find the total capacitance when connected in series. When connected in series. Second one, when connected in parallel. Now I am giving capacitor values, that is C1 equals to 5 microfarad, C2 equals to 10 or 2 microfarad, and C3 is equals to 10 microfarad. Okay, so C1, C2, C3 value I have given. Just find the total capacitance when connected in series as well as in parallel. So first connection, find the total resistance when connected in series. So this is a series connection of three capacitors. One is C1 and C2 and third one is C3. Okay, so these are connected in series. Okay, here he didn't given any supply, just find the total capacitance when connected in series and in parallel. Now this is C1, C2, C3. What is the value of C1? 5 microfarad and C2 is 2 microfarad. Now C3 is 10 microfarad. For capacitors are in series, what is the equivalent capacitance ma? That is 1 by C total equals to 1 by C1 plus 1 by C2 for series connection. So 1 by C total is equals to 1 by C1 plus 1 by C2 plus 1 by C3. Okay, this is for series connection. Capacitors are connected in series. 1 by C total is equals to 1 by C1 plus 1 by C2 plus 1 by C3. So now 1 by C1 is nothing but 5. Microfarad is common for 3. Just consider it as microfarad, that is the unit. So micro means what is the value of microfarad ma? Convert into normal farads, that is 10 power minus 6 farad. Okay, micro is nothing but 10 power minus 6. Okay, so 1 by C1 is 5 plus 1 by C2 is 2. Now 1 by C3 is 1 by 10. Just to do LCM for that. So what is the LCM of 5 to 10 ma? See, 2, 5, 1, 5. So 5, 1, 1. So 5 2s are 10. So here LCM is 10. So now 1 by C total. So 1 by C total is equals to, what is the LCM of these three? 5, 2, 10 is 10. Okay. Now here denominator 5 is there. So multiply with the 2. 2 into 1 gives 2 plus here denominator 2 is there. So 5 plus here denominator 10 is there. Consider 1. Okay. So now 5 plus 1, 6, 6 plus 2, 8, 8 by 10, 8 by 10. Okay, now we need to consider C total. So, C total is nothing but just 10 by 8. This is the microfarad capacitance. Okay, so 10 by 8. Okay, now C1, C2, C3 are connected in series. The total equivalent capacitance is 1 by C total equals to 1 by C1 plus 1 by C2 plus 1 by C3. Now, it is not possible if suppose we need to consider another method we have to follow. So, that is, if three capacitors are connected in series, the formula of C total is equals to C1, C2, C3 by C1, C2 plus C2, C3 plus C3, C1. This gives the direct formula for total capacitance. See, C1 means how much C1? 5 into C2 is nothing but 2 and C3 is nothing but 10. Okay, by C1, C2, 10. 5 into 2 means 5 into 5 into 2 plus C2, C3 means 2 into 10 plus C3, C1 is nothing but 10 into 5. Okay, now here 5 into R, 5 2s are 10, 10 10s are 100 by 5 2s are 10 plus 2 10s are 20 plus 50. Okay, now 100 divided by 50 plus 20 70, 70 plus 10 is 80. So 0 0 get cancelled, 10 by 8. Okay, previous method also we can get same value, that is 10 by 8 microfarad. So both methods we can follow. Okay, now if capacitors are connected in parallel. So first question is completed, that is series connection. In series connection we get a 10 by 8 microfarad. Now coming to parallel. So for parallel connection, what is the total capacitance? What is the formula for parallel combination? So for parallel, 3 capacitors are in parallel. C1, C2 and C3 are connected in parallel. Okay, he didn't give any supply, so just consider only parallel combination of capacitors. This is C1, C2, C3. C1 is 5 microfarad, C2 is nothing but 2 microfarad, C3 is nothing but 10 microfarad. So what is the formula for parallel combination capacitance? C total is equals to C1 plus C2 plus C3. Now what is C1 ma? 5 microfarad plus 2 microfarad plus 10 microfarad. So 10 plus 2, 12. 12 plus 5, 17 microfarad. Convert into farad ma. What is the value of micro? 10 power minus 6 farad. Okay, this is the total capacitance of 3 capacitors. Okay, so I hope all of you understood for the capacitors are connected in series and capacitors are connected in parallel. So resistor values completed, capacitors completed. Now coming to inductors. So same question. So find the total inductance. Find the total inductance. Find the total inductance when connected in series and parallel. Now I am giving the inductor values ma. So L1. So L1 is equals to 3 millihenry. Okay. L2 is 5 millihenry. L3 is 10 millihenry. L3 is 10 millihenry. Now consider series connection. For series, what is the formula for the total inductance in series ma? L1 plus L2 plus so on Ln. So L total is equals to L1 plus L2 plus here L3. Now what is the value of L1? 3 milli. Milli means 10 power minus 3. All are in milli only. So final value is also in terms of milli. So 3 plus 5 plus 10. Total 15 plus 3, 18 millihenry. So what is the value of millima? 10 power minus 3 Henry. This is the total inductance when connected in series. Now coming to parallel. So for parallel connection. So for parallel, okay, what is the formula for parallel connection in for inductance ma? 1 by L total equals to 1 by L1 plus 1 by L2 plus so on 1 by Ln. So 1 by L total is equals to 1 by L1 plus 1 by L2 plus 1 by L3. Just by solving this, from this we can get L total, that is L1 L2 L3 by L1 L2 plus L2 L3 plus L3 L1. Just to substitute these three values there, then we'll get the total inductance. So L total is equals to L1 5, L2 L1 is 3, L2 is 5 and L3 is 10 divided by 3 into 5 means 15. Then 15, 5 into 10, L1, L2 is 5, L3 is 10. So 5 into 10 means 50 plus L3, L1. L3 is 10, L1 is 3. 3 into 10 is nothing but 30. Now what is the value of L total here? Totally 10 into 5, 50. 50 into 3, that is 150 divided by 50 plus 30, 80. 80 plus 15, 80 plus 15, 95. So in terms of millihenry. Okay. So for series combination completed, parallel combination completed. So series are connected, inductors are connected in series, follow this formula, and in parallel follow this formula. Okay. So now based on series and parallel, we can consider another method, that is combination of series parallel. Combination of series parallel connection. So now suppose he given the series and the parallel combination. So find the total resistance. Find the total resistance for the following circuit. Now this is the circuit ma. It is the combination of series as well as parallel. Series as well as parallel. Series as well as parallel. Okay. Now I am considering 2 ohm, 2 ohm, 2 ohm, 1 ohm, 1 ohm, 1 ohm. Okay. This is A terminal, this is B. Find the total resistance from A to B. So first of all, consider the parallel. Here these two are in parallel. So based on parallel connection formula, we can get one total resistance here. So what is the formula for total resistance when connected in parallel? That is R1 1 by R1 plus 1 by R2. That is nothing but R1 R2 by R1 plus R2. So now this circuit as redrawn as, this is, I am considering R1, R2, R3, R4, R5, R6. Just I am assuming. Now here R2 and R3 are in parallel. Okay. So first do parallel connection for these two only. Okay. So now R2 and R3 both are in parallel. So we can get this is R1 and this is this is A, this is B. Now this R1 is common and this R4 is also common. Now coming to R2 and R3, these two are in parallel. So for parallel combination, here R1, R2, R3 by R2 plus R3 formula, that gives the R total for this combination. So 2 into 2 divided by 2 plus 2. So this is 2 into 2 by 2 plus 2. So that gives 4 by 4. That is nothing but 1 ohm. Okay. So now for this resistor, it is 1 ohm. Okay. Just simplifying these two, then we'll get 1 ohm resistance of this resistor. Now coming to this point, here these two are in series only. So for series combination, R5 plus R6, that is 1 plus 1, that is 2 ohm. Okay. Now this total circuit redrawn as like this path. So here R1 is same, R4 is also same. This is 2 ohm and this is 1 ohm. This is 1 ohm. But these two are in parallel. So product of those two resistors by sum of those two, then we'll get 1 ohm here. Now this is these 1 ohm and 1 ohm, these two are in series. So sum 1 plus 1, that is 2. Now consider 1, 2, 3 means 2 ohm, 1 ohm, 1 ohm. These are in series. So again redraw that circuit as one resistor and this one is 1. So 1 plus 1 is already we know 2 ohm and here 2 plus, what is this resistor? 1 plus and this resistor is 1. So finally we get 2 plus 1 plus 1 is nothing but 4 ohm for this resistor. Here 2 ohm. This is A terminal, this is B terminal. Now this 4 ohm and 2 ohm both are in parallel. Now we can parallel it. So RAB is equals to 4 into 2 by 4 plus 2. 4 2s are 8. By 4 plus 2 means 6. So 2 3s are 2 4s are. So now RAB is equals to 4 by 3 ohm. This is the total resistance for this circuit. Okay. So basically it is a complicated circuit just look like, but based on the series and parallel combination it is very easy. Just follow the formulas of series and parallel connection. So now here R2 R3 are in parallel, so just total it, then we'll get 2 into 2 by 2 plus 2, then we'll get 1 ohm here. Now those three are connected in series, so finally we get 4 ohm here, for this 2 ohm. Now these two are again in parallel, so just the product of those two by sum of those two, then we'll get the RAB, total resistance across AB terminals. So like that we can consider the series parallel combination of each passive elements. Okay, so now series completed, parallel completed, series and parallel combination problems completed. Now thank you one and all.